Hello everyone, and today I will derive the likelihood function for Cox-PH model when there is no tie in the data. See, when there is no tie, for a little understanding, there could be two situations can occur when there is a tie and when there is no tie. So when there is a tie, then there would be multiple event of interest occur at a certain time point. Uh, but in no tie, there will be one individual event occurring at that particular time. So we are considering for no tie, so there will be a single one. And so Cox, which is who just in 1972 proposed a special type of likelihood function, and it is for the semi-parametric pH model. So Cox proposed uh, pH proposed a model for likelihood function, and it is 1972, and he proposed it for semi-parametric model. Semi-parametric model. So how this likelihood that the Cox proposed and how it is look like, it is basically look like L beta is equal to product of I 1 to up to k, and is about Li of beta. So that kind of a likelihood that this Cox proposed in 1972. So there is a meaning. What is the meaning of the k? K is an ordered time points, and the time points begin with 1 up to k, and this beta is a parameter of interest that we would like to estimate in future. So this is it, and now there is a question: what is as a whole this Li beta means? So there is the point to be started our derivation of this Cox-PH model for no tie. See, uh, Li beta is defined as it is the probability, conditional, conditional probability that a particular that a particular individual Ji um, Ji is a particular individual at time point 1. So you have to memorize like that. Ji is like a person, like Ivan, Isha, they are the person and they're known as J. And I is the time point. Suppose Isha fails at time point 2, then we will write Isha 2. For a simple example, Isha 2 indicates that Isa fails at time 2. So that kind of thing. So let me first complete this one. Is the conditional probability that a particular individual Gi from risk set Ri fails at Ti, given that any one from Ri fails at Ti. I know it is very much confusing when I just write it in that way, but you have not to worry at all, because I will now convert it in mathematical terminology, then it will be very much easier. But first of all, you have to understand the symbols that I'm just using here. For I already discussed this one. JI is a person, individual, fails at TI, some kind of that. And RI, it's a risk set. All the persons, like there is a three person, and Ihan, Isha, Ivan, in these three persons, then it will be come up with the risk set RI. They're all included in the risk set. And TI, as we know, that is the time point, and that is it. Now I will convert it into mathematical notation, so then it will be very much easily understandable. Mathematically, what we can write mathematically, what we can write Li beta is equal to probability. We will write these things same as that. So probability of individual, from that part we will write individual Ji from Ri fails at Ti. What is given? Given anyone from see what it was given that anyone, so we will write it here, any one from Ri fails at Ti. Let me explain you this one. As I already mentioned that this Li beta is nothing but a conditional probability. So any kind of a conditional probability we write in like these terms. There is a separations, and the last part will be at like a denominator in that case. So what is the condition? Condition that individual Ji from risk set Ri fails at Ti, given that what is given. So we will write that given that anyone from Ri fails at Ti. So we'll write these things in the notation of the probability. That is it. The next what we can do, it's a very much common approach, because as I already say that this one can be expressed as probability of individual Ji from Ri fails at Ti. Okay, and at the denominator, what will be at the denominator it will be this part, anyone from Ri fails at Ti. So that is it. The next, what we can write at the next, we can extend a little bit one. Okay, so we can write as see, this probability you can write for this part and this part. Okay, so there's a mistake that I have done previously. It is not like that. This will be over that. So now I can extend that a little bit. Probability of individual Ji from Ri fails at Ti. I can write a given individual Ji survive prior to Ti. What is a prior means? As a prior means a little bit, not too much. It's kind of a quantity measured in del notation. So a very little bit prior. Suppose here, suppose this is a time point, this T. So prior to Ti, that means a little bit, and that is calculated in terms of del T. So we will have to go for greater than T. So that is what is I'm telling you, individual GI survive prior to TI. More than TI, but a little more, not too much. And the denominator, what we can write same thing. First this one, anyone from RI fails at TI, given individual survive just prior to TI. Same thing, I will write it here. Individual GI just survive prior to TI. All right. So prior, you can write as just. Okay. This prior quantity will be denoted like just a few TI. So we divided individual GI survive just prior to TI, both side. So sorry, at the both numerator and denominator. So we will get like this one. What we can do next, we can write it now from much more easy notations. So we can write as probability of an individual GI from RI fails at TI. So we can say that is the event of interest T of for GI individual, it will be TI. Given that, what is given that individual GI survived just prior to TI, So J T of JI just prior, I already mentioned, greater than TI. But you have to remember this is not too much prior, just prior to TI. And then next one is probability of T J is equal to TI, given Tj greater than or equal to Ti. Now there is a must be question. Here I write Ji, and here at the denominator I just write Dy, because this is anyone from Ri. That means anyone can be entered at that place. So Ji will have the full risk sets values, but the individual Ji will never got all the outcomes. They will get only single outcome from the risk set. So that's why we write Ji, and here we just write only J. So that is it, how it's look like. And I already mentioned that you have to understand this is for the whole. So I have to go for the summation, because at the risk set there is individual up to any number. Suppose I have risk set of Isa, Ihan, and Ivan. There are three risk set. Then there will be the summation will be applied for everyone, so that we can combine them. So the summation will become here where J belongs to the Ri. Okay, for everyone will be included from the risk set at the denominator. That's why we sum up from J up to Ri. And now what we can write, so this is some kind of a hazard notation, don't you think so? Yes, I already mentioned just prior, and that is why this is some kind of a look like very similar to just a hazard function. So we will write now, and this is not that kind of a hazard, it's not a baseline hazard. Okay, so now what we can write, h of ji of Ti, and the denominator we will get J belongs to the Ri, and there is a H of J Ti. And the next line, what we can write, we will convert it, as we already know that from the formula. It's about that when just covariates introduced, Okay, so this is the covariate introduced hazard, but now we will convert it like a baseline hazard, and how we will denote it like h naught of ti e to the power x prime j I beta, and the denominator will be j belongs to ri, and it will be h naught ti e to the power x prime j beta. Just very much careful. This is the this is come from the formula. This is with covariates, but this one is our baseline hazard, so it is not with covariates, it's without covariate. And the relationship between with covariate and without covariate, this hazard function very much look like this one. So we just enter the formula, just only that thing that we just introduced here. And why with ji? Because there was a ji, but here only j, because there is only j. Okay, so this is what, because this is as a baseline hazard, it's a constant. So for both side, for denominator and numerator, we will can cancel these parts. Then we will live with e to the power x prime j of I beta e to the power x prime j beta. So what is this? This is actually the Li beta. So we found Li beta. Now it is very much easy to find out the likelihood, because we already define you the likelihood of beta will be the sum of from 1 to up to k, where k is ordered time points, and it will be Li beta's product. So now L will be product of I up 1 to up to k, and it will be Li beta. So another way, 1 from k, and it will be e to the power x prime j I beta e to the power x prime j beta. So this is the likelihood, and later videos we will introduce you the estimation process of this beta. So thank you very much for this session.